This topic is called multiplying rational expressions. Rational expressions are just fractions, basically. But before we jump in and start doing that, I just want to review a couple of the exponent rules. So if we have something like y to the second power times y to the fifth power, what we do with those exponents is add them. So we'd end up with y to the seventh power. You might want to write these rules just as a reminder down into your notebook. So why don't you pause this until you get your notebook out, and then we'll go from there. Another rule of exponents is if you have like x to the third and you're raising it to another power, say to the seventh power, what you do there is when you raise a power to a power, you multiply those together. So you would have x to the 21. So those are two main rules of exponents. And just as another reminder, if we have something like this, 3a squared times 2a to the eighth, what you want to do is take your numbers first, the coefficients so to speak, and you multiply them. With 3 times 2, that's going to give you 6. Then you can just isolate your a's. Then it's just like this rule here. You multiply a squared times a to the eighth, but what do you do with the exponents? You actually add them. So 2 plus 8 will give you 10. So that's how you handle it if you have a couple of what we call monomials multiplied together. Alright, so let's basically use those rules. Let's walk through a couple of problems where we multiply rational expressions. So we're multiplying fractions together, and when we bring in a lot of letters and stuff, what we need to do is simplify them with the rules of exponents, and then multiply tops times tops and bottoms times bottoms. Alright, so let's have 8y over 3a times 9ay over 2y to the fifth. And what I would do is take care of your tops first. Well, I mean, you can do it a couple ways. You can either just multiply your tops together, multiply your bottoms together, and then simplify, or if you want, you can take some fractions and do some reducing as you go through it. To me, I think the most straightforward way is just let's take care of the tops to get one single top expression, multiply the bottoms, get one single bottom expression, and then do any simplifying that we need to do. So if we look at the tops times the tops on here, 8 times 9, that's going to give us 72. When we look at our a's, we only have one a at the top. And in the bottom we have, and at the top for y's, we have a y times y, which will just give us y squared. For the bottom, number-wise, we have 3 and 2, and they need to be multiplied, so that's going to be a 6. We only have one a, so that's going to be just an a. We don't usually write to the 1 power. And then y to the fifth is just really copying that over. So now what we want to do is a couple things. We want to take the 72 over 6 and reduce it or divide it, whichever works better. In this case, 6 does go evenly into 72. So 6 goes into 72 12 times. So we now have a 12 on the top, and we can put a 1 on the bottom. That's what it's reduced down to. When we look at our a's, we have an a over an a, and when you're dividing those out, they're just going to cancel out. They're gone. Finally, we have a y squared over y to the fifth. If you write that out in longhand, it's y times y on top, and on the bottom, 1, 2, 3, 4, 5, and then we cancel some out. We get that one canceling with that one, and where do we have y's left? We don't have any y's left in the top, but we do have 3 y's in the bottom. So there we go with our y to the third. To make it look a little bit more cleaner, you could just put 12 over y to the third power. So when you're multiplying rational expressions, or fractions basically, with numbers and letters, I would multiply your tops together, then multiply your bottoms together, and then simplify from there once you have one final fraction. So let's try another one. Alright, let's see. Move this stuff up. And let's try 8b to the third times c squared. We'll put that over c to the fourth times, and our other fraction we'll do 5 c to the first power over 4b to the fifth. Again, let's just look at the tops times the tops. We have 8 times 5, that's going to give us 40. So we're multiplying the numbers even though we're going to be adding exponents. When we look at our b's, there's only one chunk of them, b to the third. But when we look at our c's, we have c to the squared times plain old c, which is c to the first, and that's just going to be c to the third. Now we do the same sort of thing on the bottom. There's no numbers except the 4, so we're just basically recopying it, and there's no other C's except C to the 4th, and no other B's except B to the 5th. And again, maybe I'll go and do some more baby steps in this, which tear it apart a little bit more. We're doing this first. We're isolating the numbers together. We have 40 over 4. Well, that reduces to 10. Now I'm going to look at my B's. I have B to the 3rd on the top and B to the 5th on the bottom. Again, if we have 3 B's on the top and 5 on the bottom, they're all going to cancel out except for 2 on the bottom. So we have that. The last thing I need to look at is my C's. On the top I have a C cubed. On the bottom I have a C to the 4th. And if I write out my 3 C's on top and my 4 on the bottom, they're all going to cancel out except there'll be 1 left over on the on the bottom. So now what I want to do is combine these 3 answers. I have a 10 on the top, I have a B squared on the bottom, and a C on the bottom, and then you're all done. So if it intimidates you trying to do it in your head and looking at this huge problem here, which might be, I don't know, some people there's just too much to take in. Break it out. Put your numbers over each other, put your B's over each other, put your C's over each other. Just take it one bit at a time and then combine it all back into one answer. We're going to try one more, and what I'm going to have you do is try, if you're ready for it, hit pause after you write down the problem. Try doing it in your notes, then hit play and see if you get the same answer that I do. We'll do 2 more problems total. Okay, scoot this stuff up. Scoot. Let's try 6m squared n to the 5th over 5m times, we need another fraction here, let's do 4m to the 7th n, and then on the bottom of that we're going to have 2n to the 3rd m squared. Again, let's just multiply our tops across and multiply our bottoms across and then deal with it from there. 6 times 4, those guys are going to be multiplied, that's 24. For our m's, we have an m to the 2nd and an m to the 7th. We add those exponents, so that gives us m to the 9th. For our n's, we have an n to the 5th, and this here is technically an n to the 1, so we're going to end up with 6 n's, or n to the 6th power. That takes care of our top. The bottom, we have 5 times 2, and again, those are being multiplied. Multiply the numbers, add your exponents. On the bottoms for m's, we have an m to the 1st power and an m to the 2nd power, so that gives us m to the 3rd. And all we have for n's is also just an n to the 3rd. Alright, let's look at 24 over 10. This is not going to divide out evenly, but we can reduce both of those by 2. So 24 divided by 2 gives us 12. 10 divided by 2 gives us 5. Now if we look at our m's, we have m to the 9th over m to the 3rd. Again, if we have 3 m's on the bottom and 9 on the top, we're going to end up with 6 left over. You're basically, honestly, just subtracting those exponents and putting the leftover ones wherever the higher exponent is. So 9 take away 3 gives us the 6. Why did I put the 6 in the top of the fraction? Because that's where the 9 was, and it's bigger than the 3. Last, we have our n's. We have n to the 6th over n to the 3rd. Same deal. 6 take away 3 is going to give us to the 3rd power. And where do we have more n's? Well, we started with more n's on the top, so that's where it's going to be. Alright, so we combine these all together. We have a 12 in the top, a 5 in the bottom. We have an m to the 6th in the top, and an n to the 3rd in the top. And there you go. Did you get the same answer? Alright, we have one more to try. I would suggest even if you got this one right, it wouldn't hurt to do one more, just to kind of get the feel of it, make sure you know what you're up to. Alright. Let's see, let's do 3p to the 3rd q to the 10th r squared over 2p q to the 7th times, let's do 8p to the 5th r to the 9th, and then on the bottom of that fraction, what sounds like a good number? 5? 5, let's just do r to the 6th power. Again, let's just start with tops times tops. and then bottoms times bottoms. So on the top, our coefficients, or the numbers we need to multiply, is 3 times 8. That's going to give us a 24. If we look at all our p's, we have a p to the 3 times a p to the 5th. That's p to the 8th. Q's, all we have is a q to the 10, so we're just copying that over. And then for r's, we have an r to the second power and r to the 9th. When we add those, we get 11. That's our top. For the bottom, we multiply our numbers. 2 times 5 is going to give us 10. And any of the same letters in the bottom, we're just going to add any exponents. However, we don't have any of the same letters, so we just copy everything that's there. P, q to the 7th, r to the... I'm outside and my dog is barking. Alright, so like I was saying, on the bottom we just have 10, P, Q to the 7th, R to the 6th, just like the letters already were in the bottom. Now we can start isolating the numbers and look at those, and then isolating each of the letters and looking at those. So 24 over 10, again, they can't be divided evenly. I think we just had these two numbers. We're going to divide both of them by 12. Sorry, we're going to divide both of them by 2, and that's going to give us 12 in the top. And on the bottom we have a 5. Alright, so those are done. Now we look at the p's. We have 1 p on the bottom and 8 of them on the top. If we subtract 8 minus 1, we're going to get 7. And the 7 that are left over are going to go in the top, because that's where most of the p's came from. When we look at our q's, we have q to the 10 on the top, q to the 7 in the bottom. So 10 minus 7 leaves us with 3 q's, and they're going to also be in the top. Finally, we look at the r's. We have r to the 11 on the top, r to the 6 on the bottom. 11 minus 6 is going to leave us with 5 r's, and again, they're also going to be on the top because most of the r's were on the top to begin with. There you go. I hope you got the same answer that I got. If you have any confusions and you want to come find me for some clarification, definitely do that, and I'll talk to you later.